Okay, this video is going to be about pressure versus volume, so we're going to go ahead and go to that tab. And first, I want us to remember what we're talking about when we're talking about pressure and volume. So for pressure, I'm talking about my number of collisions. So how many times are those particles hitting each other, or are they hitting the walls of their container? And then volume is all about space. How much space is it taking up? So these are inverse, meaning as one increases, the other decreases. Okay, so I gave us our two arrow options up here. You'll see what I mean by that in just a second. So let's go ahead and jump into our first question on here. As I read, I'm going to underline things that are important, or I think may be important, so that I'll be ready to use those. So if I have 5.6 liters, okay, that's a number, probably going to need that, of gas in a piston at a pressure of 1,140 millimeters of mercury. I'm going to underline that. And you compress the gas until its volume is 4.8. So compress means to make it take up less space. What will the new pressure, so I'm looking for pressure, inside of the piston be? So I know I have volume and pressure here. So I'm going to do V1, P1, V2, P2. So these are two different groups. So group 1 and group 2. So it said if I have 5.6 liters, that's my volume, because liters is a unit of volume, 1,140 millimeters of mercury, and then my second volume is 4.8 liters, and I'm looking for that pressure, so I'm going to put in X. Now I need to make sure that my units are matching here. Liters, liters, got it. So my answer for this pressure is going to be in millimeters, of mercury. So we have pressure, we have volume, so we're going to make a little chart here. And the first thing I'm going to do is write the numbers for the couple that do not have the X. So these already have both numbers, so I'm going to go ahead and write that in my table. Put an X there. That's what I'm looking for. So once I've taken the information from the paragraph or question into my variable breakdown, I'm going to put it in my table, and now is when I'm going to start to analyze it. So 5.6 to 4.8, that's a decrease in volume, so I'm going to put a down arrow. Now we talked about a second ago that our arrows are going to be opposite because this is an inverse relationship. So if volume goes down, pressure is going to go up. Now the arrow I really care about to do my math is the arrow with the X. So I always circle that to kind of remind myself. So I'm going to take this number that's by itself right here, and I need to multiply it by a fraction. Now this arrow is pointing up. So that tells me that my fraction has to be greater than 1. That pointing up tells me that of these two numbers, my bigger number has to go on top of my fraction. So because I need that to be greater than 1, my larger number goes on top of my fraction. Get my calculator out here. I'm going to do 1,140 times 5.6 divided by 4.8. And I end up with 1,330. And my unit here is going to be millimeters of mercury. Now do not forget, we have to look at our sig figs. So let's do sig figs here. I have 1, 2 sig figs there, 1, 2, 3 sig figs there, 2 sig figs there. So my answer can have 2 sig figs. So I got 1, 2. I say, what does that 3 do to that 3? Nothing. There is our final answer. Do not forget to keep that 2 place holding zeros there. Okay, let's go ahead and look at our next question here. This says Courtney added 15 liters, probably going to need that, of air to a balloon at sea level. So I tell you that sea level is 1 atmosphere. If Courtney takes the balloon to Denver where the air pressure is 0.85, so there's another pressure, what's the new volume of the balloon going to be? So again, I'm dealing with volume and pressure here. So I'm going to do V1, P1, V2, P2. I had 15 liters when it was at 1.0 ATM. Now make sure you're keeping that 0.0 because right there is a sig fig. 0.85 ATM. And I have my X there for my placeholder. Now both of these are in atmospheres, so I'm good to go ahead and make my little table here. So I'm going to start with the one that already has both numbers. So my pressure is 1 ATM, 15 liters. So from 1 to 0.85, my pressure decreased, which means my volume is going to increase because these are inversely related. So I'm going to circle that arrow with my X to remind me what I need to be doing here. So I have 15 times. Now I need to set up my fraction. My circled arrow points in the direction where my larger number needs to go. So this arrow is pointing up, so my larger number needs to go on the top of the fraction. Okay, when I put that in my calculator, I get 17.64706. Now let's talk sig figs here. I have 2, 2, 2. So my answer is going to have 2 sig figs. So 1, 2. What does that 6 do to that 7? Rounds it up. So I end up with 18. And then my unit here is in liters. Okay. Let's go ahead and look at the next two. So this one says, what will the pressure of oxygen be at a volume of 150.0 milliliters? So it says, what will the pressure, so I'm looking for pressure, be at the volume of 150 milliliters if a sample of oxygen gas has a volume of 134.9 milliliters when its pressure is 1.05 atm. The temperature remains constant. If you ever read something remains constant, that's usually telling you that it's okay to ignore it. So I'm not going to worry about temperature here. I'm only going to be worrying about pressure and volume. So I'm going to put my P1, V1, P2, V2. Now the very first thing it says is, what will the pressure of oxygen be? So I'm looking for this pressure when I have 150.0 milliliters of oxygen. Now when the volume is 134.9 milliliters, the pressure is at 1.05 atm. So notice this time our P1 is our X, not P2, because that's how our problem read. Now if you wanted to write it opposite, that's fine, as long as these two numbers go together and the X is with the 150 milliliters. So let's go ahead and make our little table here. I need to write in the couple that's already complete, so the couple that has two numbers. So I'm actually going to put couple 2 in here first. So 1.05, my volume. We're looking for that pressure. So my volume from 134.9 to 150 went up. So if volume goes up, pressure goes down. Again, I'm going to circle that arrow with my X to remind me how I need to set up my fraction. So I'm going to go ahead and write my number, 1.05. The arrow is pointing down because I need my fraction to be less than 1. So my larger number is going to go on the bottom. Put that in my calculator. And I get 0.9443. Now looking at our sig figs here, I have 4, 3, and 4. So I'm going to need 3 sig figs in my answer. Remember, this 0 is not a significant figure, so 1, 2, 3. What does that 3 do to that 4? It leaves it alone. And my unit here is going to be in atmospheres, ATM. Last example on this one. Jefferson has a car with an internal volume of 12,000 liters. So that sounds pretty important. So I'm going to underline 12,000. If he drives his car into a river and it implodes, what will the volume, so I'm going to be looking for volume, of the gas when the pressure goes from 1 atm to 1.9 atm? Now I included this one because it takes a little bit of thought to figure out what our couples should be. So I'm going to go ahead, I know it's pressure and volume, so I'm going to do my P1, V1, P2, V2. I start out with an initial internal volume of 12,000. So I'm going to go ahead and write that. Now when I'm looking at my pressure, it says goes from 1 atm to 1.9 atm. So it's starting at 1 atm. So since I'm starting there, that's what I'm going to put here. I want to know what this volume is going to be when I'm at 1.9 atm. So sometimes you need to take a second just looking at the question to pull out the correct information. So now I'm ready to put this in my little table. So we've got 1 atm, 1.9 atm, 12,000 liters, and I want to know what my new volume is going to be. So pressure went up, so volume is going to go down, inverse relationship, and I'm going to be looking at my arrow with my X. So I'm going to go ahead and write this number that's by itself, multiply it. My arrow with my X is pointing down, so I need my fraction to be less than 1, so my big number is going to go on the bottom. Where this arrow with the X points tells you where your larger number is going to go. Let's see what we get. So let's check our sig figs here. We have 2, 2, 2. So I can only have 2 sig figs in my answer. So 1, 2. Got to say, what does that 1 do to that 3? Absolutely nothing. Do not tell me it's 63. 6,000 is very different than 63. So we got to make sure that that 6 stays in that thousands place. So I need to add 2 placeholding zeros here. And my unit is in liters. So that was a look at pressure versus volume calculations.